In this sample app, every export starts using hundreds of megs of RAM. But with a more optimized implementation, memory usage is almost unnoticeable. Want to learn how to build optimized exports and monitor memory usage in your Elixir app? Stick around. This is Code and Stuff. Almost every app I've ever worked on has ended up needing a CSV export feature. While it's possible to create fancy filtering UIs that let customers slice and dice the data you're holding onto for them, for some folks, there's just no substitute for Excel. But there's a problem. Processing that much data requires a ton of memory, and in multi-tenant SaaS apps, that can get disruptive and expensive. In some regions, there might even be regulatory requirements to make a customer's data available in a portable format. Using Elixir Streams, we can process the data chunk by chunk and get large exports to many users at the same time without running out of memory. This has the added benefit of allowing them to start parsing and processing the file while we're actively sending them more bits. As always, code from this project can be found on GitHub with a link in the description. To begin with, I want to show a demo app that keeps track of employee timesheet records. After cloning the project down, I'm going to run mix ecto setup to run database migrations and insert 100,000 fake records. These records come in through a file called seeds.exs, and I find that it's useful to provide these types of scripts and repos so folks can get started developing in a codebase without having to deal with a complicated setup page and manual clicking and all of the stuff that goes into making a full app that's more production-like. Now that the database has some data, I'll show you what it does. I'll start the server with iex-s mix phx.server. One of those things you just got to keep on remembering as you work with Phoenix apps. On the homepage of this app, it just shows a table of timesheet records. It does this 100 entries at a time entirely with boring server-rendered HTML pages. I can click next and get subsequent pages of data, but the main thing I want to show today is this export button. When I click it, a massive CSV is constructed and sent down. It takes a few seconds to download even on localhost and ends up looking something like this. This is 100,000 rows of fake employee time records, all the way down to the bottom, 100,000. I built the first version of this in a pretty unsurprising way. I grab all of the records and then map them into a timesheet entry structure, and then use Nimble CSV to get that structure into a CSV format. Then I say this is a CSV file. It has a name timesheetentries.csv. Send that response body, and I'm done. Behind the scenes, this list timesheet entries function is just a repo.all with a few filters. But the biggest issue here is that the export handler holds all 100,000 fully hydrated struct entries in memory and then duplicates some of that data in string form when it constructs the response body. This is not efficient at all. That memory isn't garbage collected until all references leave the scope, which is something that only happens when the HTTP response is completely finished. Erlang, and by extension Elixir, has a built-in monitoring UI called Observer. Some of this data is also visible in the Phoenix Live dashboard, but the refresh times on Observer are much more granular. To run Observer, in my live server down here, I will run :observer.start. This will launch an app that I'll just drag in here. If this command doesn't work for you, you might need to make sure the feature is enabled in your Erlang installation and the Observer and WX applications are registered in your mix.exs file. I've already done that in the mix file of this repo, so if you download it, it should just work. But yeah, if there's an issue, go take a look at how to enable Observer in your Erlang installation. So I'll go over to the Load Charts tab, and let's start a download. On the left, I've got memory usage, and on the right, I/O. And it looks like this application, during the download, peaked somewhere around 700 megabytes of data, and I'm only handling one request. Obviously, a server that handles requests from many users at a time will pretty quickly crash with an out-of-memory error. So, what's a better way of doing this? In Phoenix, a connection can be set to a chunked response mode with a function called sendChunked. Then chunks of data are sent using the chunk function. Data collection processing in Elixir typically falls into two categories, eager and lazy. They're represented by the enum and stream modules, respectively. With a stream, the data isn't processed immediately. The theory is, if we only use stream methods, rows will go through all of their transformations and get used immediately without us needing to keep all of those intermediate copies around and without needing to hold all of them at the same time. The Ecto database library has a built-in stream function that returns a native Elixir stream of database results, and it might seem like a good fit at first glance. The problem is that this function requires a long-running database transaction that your database might not be happy about. This might work for your purposes, but I'm going to go to a slightly lower level. Down here, I have a handler called export stream, and I'll walk you through it. I make a stream using the stream.resource function, which takes 3 callbacks. The first is an initialization function, which I'll use to create an initial cursor value of 0. This list timesheet entries function supports cursor-based pagination with a batch size limit. In the second callback, I do the actual fetching. Given a cursor value, fetch some number of records, and if I get fewer records than I'm expecting, then I must be on the last page. When I get full pages, I return the records and set the cursor value to the highest ID that I've seen. Finally, the third callback is just a cleanup function. There's nothing to clean up, so I just say, okay. At this point in the handler, we haven't actually done anything. The stream resource is lazy, so it's just sitting there ready to provide data when asked. So I'll set some HTTP headers and then enable a chunked response and send the first line of the CSV. The first line of that CSV is just those header values. Then the magic happens. I'm mapping each entry into a CSV row the same way that I did before, but I'm using the stream module to do it and a stream function in Nimble CSV. Then I collect it into enum.reduce. Remember that the enum methods are ones that actually are eager and evaluate. So it goes line by line, taking in the connection, sending a chunk of data out on that connection, and then going through to the next one and to the next one until we reach that halt in the stream. While I was editing this video, I found out that the reduce while function is preferred because the chunk send could fail. So take a look at this. This is probably a better way of doing it. Anyway, back to old me. So I'll go over to the router and switch our export function to export_stream and fire up observer. Bringing that into play, going to the load charts here, I'll hit the export button and we can see what happens. My memory utilization is now floating somewhere around 70 megs, and I can keep on hitting this without getting very much more memory used. It turns out the Beam is really good at handling a ton of I/O. That's why it's used in tools like RabbitMQ and apps like WhatsApp. It's really easy to get something working in Phoenix, and with a little extra thinking, it can be optimized for a production scenario. Most Elixir videos rush into WebSockets to show fancy features of frameworks like LiveView, but there's so much more to love in the Beam. If you found this useful, consider giving this a like or subscribing for more content like it. If you didn't, I'm sorry for wasting your time. This has been Code and Stuff. Thanks for watching.